You're going to use your x squared plus y squared equals r squared. You're going to use your x equals r cosine theta, and our sine theta equals y. And that deals with x and y. And let me just put off a circle right here. Alright, so let me just go ahead and check. If you have any questions on the first few, and you should kind of recognize that they do look the same when you get there. On 35, this is a 1. Cosine squared plus sine squared equals 1. So we can take this out. That's your identity. Anything that deals with your x and your y, cosine sines, is what we're looking to convert. So we can get this out of here. Then we factor out an r. Remember, r equals 0 can't happen because you won't get a circle. So this one's left. Now, if you put this in your r equals, you will get a circle. That's a little bit offset because only one of them had complete the square. A means any number. So if you want to put it in your calculator, just give A a number. Give A 1. A means any number that you put in there. It's just offsetting your center of your circle. So when we use A, just replace it with a number, or in this case, with 1, just not 0. Actually, you could replace it with a 0. It just doesn't offset your center. Okay. Good? Because of the glare. If you take, before you sit down, Gabby, one each of these sheets that are hanging out on those two desks, that's the review. Thank you. Okay. Should we move along? Alright. And again, they look a little strange, but don't forget, your R is a circle, a radius that you're looking for, and your cosine and your sine represent your x and your y through your angles. So it's just making this so that we can go to a polar. If they look strange, the only way really to check them well is to check them on your calculator. Put it in your R equals, and see, this should give you the equation of what? No exponents. So what's that an equation of? Y equals mx plus b, a line, right? So when I put this in, shouldn't I get a line? Anybody remember doing these? Jump to polar. Let's put this in your R equals. I don't even know if I should attempt this calculator today. Looks a little bit better than yesterday. And Thursday, Friday. So let's see this first. I think this is set up for my parametric, so I might have to change the window. There's your line. I just didn't go the rest of the way down. Okay, so you should be able to graph these and see that it looks just like your rectangular one. Okay. Then go in the opposite way. Again, you're going to use your tangent. You're going to use your x squared plus y squared equals r squared. Generally, whenever you see r squared, substitute that out. I just stuffed this in here so you remember to that you'd see that I replaced it with your r squared, because you want to get your r squared out of there in terms of x and y. You want to get your cosine theta out of there in terms of x. You want to get your sine theta out of there in terms of y. So you're going back to your x and your y's. So if you graph this and saw this was a circle and you graph this or complete the square for this, it's a circle with the center offset. These coefficients are 1, and all you're going to do is complete the square. I think 49 we did something real similar with the pi over 3, right? We did a pi over 3 one. It's just one of your special right triangles. Find the slope. Slope is the same as your tangent, y over x. I find it a little harder to convert this way in terms of for you guys, because it takes a little longer to see how to get the sines and the cosines out of there. Did you find the same? Was it easier to convert the other way? Yeah. It's a little bit longer this way, but the only good thing is when you get down to the y equals, you can easily see what that is. And there's your line with the slope. It's kind of nice to see. Oops, wrong way. Okay. You want to get your cosecant out of there, convert it to sine first. You got the only way to replace sine y with sine theta with a y is if it says r sine. So cross multiply it and then replace it. A good thing to do is put it in the r first and see what it turns out to be. If it's a circle, you know you're going to have squares in there. If there's a line, you're not going to have any squares in there. An x equal you can't graph, but a y equals will graph. What would this be an equation of? Not a circle. Can't be a circle. It's going to be what? When the two x and y's are different signs. Hyperbola. If x and y have the same sign, ellipse. If x and y have different signs, hyperbola. And we don't know if they're going to get reversed, but because they're different, they're going to stay different. If I divide by a -1, they're still going to stay different. So when you graph this, you should see a hyperbola out there, some kind of hyperbola. And this will give you a hyperbola. Again, to get the r out, you're going to need your x squared plus y squared. That's your Pythagorean. C squared equals a squared plus b squared. Same thing with your radius, though. It's probably one of the longer ones. Questions at all? Or just you're following the process of replacing? Your goal is to get rid of the sines, the cosines, replace them with your x and your y's, get rid of the r squares, replace them with your x squared plus y squared, and you're into a rectangular. Okay, and that was it.